Welcome to the CVDL tutorial. CVDL is the CyberSoft Virus Description Language. It's used to define patterns as used by VFind, the VFind security toolkit for detecting viruses. VFind, however, is a general-purpose pattern matching program, and CVDL is a general-purpose pattern description language. After going through this tutorial, you should be able to write your own patterns for matching viruses or other things such as spam, sexual harassment content, top secret leakage of information, or whatever your need may be. CVDL is a small language, and this tutorial only has about 20 parts, each a few minutes long. After studying this, you should know everything there is to know about CVDL. My name is Rick Perry. I'll be your guide on this tour of CVDL. I'm a professor of electrical and computer engineering at Villanova University full-time, and part-time for the past year have been working as a consultant with CyberSoft, improving VFind to make it run faster, use less RAM, also adding enhancements to CVDL. We call virus descriptions VDLs. Actually, they should be called just VD for virus description, but VD has some negative connotations of a different kind of virus, so we call them VDLs. The format for specifying a VDL is a colon followed by the name of the VDL, which can consist of any characters other than a comma. The name is terminated by a comma, and then comes the definition, which is terminated by a pound sign. In the definition of a VDL, we use a sequence of patterns and operators. The simplest kind of patterns are literal strings using double quotes. You can also specify any type of binary character in a string using a hexadecimal notation, \x followed by 2 hex digits. Also, with strings, you can use the tilde operator for case sensitivity. The simplest kinds of operators in a VDL definition are the logic operators, logical and or being the primary two, and CVDL also includes exclusive or and the not or negation operator. Let's start by looking at the CVDL string and logic examples shown here. As we go through CVDL, for each operator, we'll show simple examples of using it. In this case, the first example is a VDL whose name is EX1, and the VDL says pets and cat or dog. So it uses the and or logical operators and also contains patterns using strings. It's important to note that, as in most computer languages, the operators in CVDL have a precedence and associativity. The associativity is generally left to right, so that patterns are matched in the order that you would write them naturally, left to right. The precedence depends on the operators. For these particular operators, and or, and has a higher precedence than or. So in the VDL, EX1, the part of the pattern that says pets and cat would be grouped together, and then the or would apply between that and dog, as shown in the second writing of EX1, where literal parentheses are used to illustrate the precedence. If the natural precedence of the operators is not what you need, you can simply use parentheses to force the order to be done in the way that you intend. Probably for this VDL, what was intended is to match pets and then either cat or dog in the scanned data. It could also be written in a more verbose form, as shown in the second example of the EX2, pets and cat, in parentheses, or pets and dog. In that final example, the second EX2, the parentheses actually are redundant and aren't needed, but parentheses can always be used to make the VDL more clear. In addition to the and or logical operators, CVDL also includes logical operators for exclusive or and logical negation, or not. Let's consider exclusive or first. In the example VDL shown, EX3 says guns and not bullets, or bullets and not guns. This may be a pattern matching rule that you could use in a scenario where your invoices for shipments can contain only guns or bullets, but not both. because you don't want them both in the same shipment. This type of pattern can be more succinctly expressed using the exclusive OR operator. So in the second form of the X3, it can be written more simply as just guns, exclusive OR, bullets. This example also illustrates the use of the semicolon to delimit a VDL comment. The semicolon and everything else to the end of the line is treated as a comment and is ignored in the VDL definition. The final logic operator, not, seems strange for pattern matching because it means that a pattern is matched if something is not found. An example where this may be useful, though, is shown in VDL EX4. Not followed by some copyright string could be used in a case where you want to ensure that all documents contain a copyright string and ones that don't are flagged as being bad. So far, we've seen the use of simple string patterns and logic operators in CVDL. To create larger patterns, we use a combination of concatenation and offset operators. The basic concatenation operator is a comma, and two patterns separated by a comma are effectively concatenated together into one pattern. In the VDL definition, the comma basically means followed by. Besides directly followed by, there is also an offset operator where you can specify that one pattern must follow another within some range of bytes. The example shown, ABC, and then the @ 0-10, the @ sign is the offset operator, specifying in this case that the string DEF must occur anywhere within a range of an offset of 0 to 10 bytes after ABC. CVDL contains two special operators, WS0 and WS1, designed to match an indefinite sequence of whitespace characters. In this case, whitespace is defined as a blank, a tab, or a backslash followed by a new line, which is a kind of whitespace used to continue to the next line in a Unix shell script. WS0 will match 0 or more whitespace characters. WS1 matches 1 or more whitespace characters. So WS0 would match an empty string or an indefinite sequence of whitespace characters. WS1, there has to be at least one whitespace character, and then there can be 0 or more additional characters. The first example shows a pattern that would match a malicious shell script which tried to remove the whole root file system. rm-rf/. In that command, the rm, the -rf, and the slash must be separated by at least one whitespace character in order for the command to operate. The second example, concatenating something into the etc password file, the cat, the greater than for output, redirection, and appending, and the specification of the password file do not require any spaces between them. So WS0 is the appropriate pattern to match a command of that form, which may or may not have white space between the elements. The third example shows a pattern that could be useful for matching a type of spam. Bulletproof web hosting. Note the use of the tilde operator to specify that the strings are to be matched case and sensitively. WS1 is used between the words because the words must be having at least one blank or tab between them for the pattern to be matched. To specify an absolute offset from the beginning of the scanned data to match a pattern, you can use the CVDL ABS operator, which stands for absolute offset. The first example, A1, shows a pattern that would match a Unix shell script. For Unix shell scripts, the first 2 bytes must consist of the characters #, exclamation point. Therefore, the VDL A1 specifies that #, exclamation point at an absolute offset of 0. Following that, in the beginning of a shell script, there may be 0 or more whitespace characters followed by bin sh, bin csh, or something like that. Example A2 just shows a random use of the ABS operator in a pattern that tries to match ABC followed by DEF within the next 20 bytes, and also at absolute position 14, the string of digits 0 to 4. The third example, MSVBA, is an actual working example which matches the 8-byte Microsoft signature header that appears at the very beginning of most Microsoft files, such as Microsoft Word and spreadsheets, and an absolute position of 0 in the file. These 8 bytes specify that it's a Microsoft file. The bytes are specified here in hex because they're non-printable characters. Additionally, there's an AND operator in there followed by another pattern with 2 bytes. Those particular 2 bytes, FVCA, are a sign that the Microsoft file contains macros. So this particular VDL for MSVBA will match if a file seems to be a Microsoft file and contains macros. In CyberSoft scanning of email to detect viruses and spam, we have found that the presence of a specific phone number is generally a clear indication of spam content for spam messages that contain phone numbers. For this specific use, we designed the tilde operator, which matches phone numbers. Actually, it performs a case-insensitive string matching while skipping any white space and punctuation characters, which is exactly the kind of matching you need to do for phone numbers that may be written in various forms, with or without dashes, blanks, parentheses, and things like that. The operator is named tilde, similar to the tilde operator, which just performs a case-insensitive match. In this case, if you specify tilde followed by a string, in that string, everything other than the digits and letters will be ignored. White space and punctuation will be ignored. In the scanned data, when this operator is applied, only the digits and letters will be scanned. The white space and punctuation will be ignored. So that first example with the 123 phone number will match that phone number in many different forms, with and without punctuation. The second example, 800 free car, just shows the use of alphanumeric characters in there, as some phone numbers are specified sometimes. That will match the phrase 800 free car while ignoring any types of punctuation and doing it in a case-insensitive manner. For the case of matching a sequence of digits and only digits, CVDL contains an operator which is spelled \D+, similar in name to the Perl operator, which performs the same operation. \D+ matches a sequence of 1 or more digits being the characters 0 to 9. This can be used, for example, to detect obfuscated URLs. The first example shown, http:// is a literal string, followed by 1 or more digits and then a slash is a sign of an obfuscated URL where the IP address is written just as a 32-bit number. Spammers generally use forms like this to hide their true location of the links. Second example shows another type of obfuscated URL where each octet of the IP address is written in octal, starting with the leading 0. And the CVDL pattern for that includes